Welcome back, everybody. Now that we've done our review of factoring and simplifying radicals and introduced finding imaginary values, we're going to talk about solving quadratic equations. When we're solving, it means we're finding the x-intercepts, both real and non-real, that would be on our graph. These can be referred to not only as x-intercepts, but also roots, solutions, and zeros. So we'll keep using these interchangeably so you understand what they're asking for depending on what test or review you're reading or textbook or website, since they were referred to many different ways. There are at least 5 methods for solving. In this section, we're going to talk about 2 methods, but for tonight, we're going to skip the solving by graphing and work on that together tomorrow. I want to head right on over to the back side of the first page and talk about solving by square roots. We're solving using the backwards order of operations, so PEMDAS backwards, which we refer to as SADMET. In order to use this, you must be missing the b term. That's this term right here that's attached to the x to the first power. A reminder to leave no radical unsimplified, and if we have negative roots, we pull out our I. So let's try a couple. In this first example, number 1, we start with adding 31 over to 49. That gives us 4x squared is equal to 80. Our next step would be to divide by 4. That gives us x squared is equal to 20. And then we undo or do the opposite of the square, which is the square root. So we have x is equal to. Now, every time we personally draw a radical or a square root on our paper, we always have the possibility of having our 2 answers. 20 is not a perfect square, so we need to simplify our radical. I'll make that 4 times 5 and 2 times 2. So we have a pair of 2's that are coming out of the house, and then 5 that gets stuck inside the house. And so x is equal to plus or minus 2 radical 5. Number 2. Start with subtracting the 9. We have 3x squared is equal to negative 9. Divide both sides by 3 next. Gives us x squared is equal to negative 3. Last but not least, we take our square root to do the opposite of the square. X is equal to, we personally wrote that square root sign, so we have our plus or minus. Now, we have a negative underneath that radical. So remember, we changed that to radical 3 times radical negative 1. Square root of negative 1 is I, and we cannot simplify radical 3. So plus or minus I radical 3 is our solution. Okay, I'm going to have you do me a favor here for example 3 and change that 2/5 to 4/5. So remember, we're looking at SADMET. If I can get this to right here, E and P. And so we have multiplying and dividing, parentheses, and exponents. Yes, we do have that plus 3, but remember, it's trapped by the parentheses. So the first thing I need to do is take care of that 4 divided by 5. The opposite of dividing by 5 is multiplying both sides by 5. So that's going to give me 4x plus 3 squared is equal to 25. Now remember, there's more than one way to do this. I'm just taking it step by step. Now I have 4 times those parentheses. So the opposite is divide both sides by 4. And we have x plus 3 squared is equal to 25/4. I don't want to make that into a decimal. I want to leave that as the fraction. And you'll see why in just a minute. I now have parentheses and exponents. So if I look at my SADMET, I have to take care of the exponent before I can do anything with the parenthesis. So I need to get rid of the square by taking the square root on both sides. That gives me x plus 3 is equal to, we personally wrote that radical, so plus or minus, the square root of 25 is 5, and the square root of 4 is 2. Our last step to get x alone is to subtract 3. So here's where we have to do a little bit more math. I have positive 5 halves minus 3 and negative 5 halves minus 3. 3 is the same as 6 halves. So 5 halves plus 6 halves is positive 11 halves. Oh, I'm sorry, we're subtracting. Excuse me. We're subtracting. So 5 minus 6 is negative 1 half. There's one of my answers. And then negative 5 halves minus 6 halves is negative 11 halves. And that's my second answer. Now those ones, if you would like to put into decimal form, that's totally fine. All right, example 4. We are going to, again, change that number in front, and I'd like you to change it to a 4. So if we're looking at our backwards order of operations, again, the first thing we have to do is to divide both sides by 4. So we have x minus 4 squared is equal to negative 5/4. Now between parentheses and exponents, we've got to move the exponents next. So we're taking the square root of both sides. That gives us x minus 4 is equal to, we personally took that square root, so a plus or a minus, the negative. The negative is going to come out as our I. Can I take the square root of 5 on the top? No, it's not a perfect square. Can we simplify it? Nope, 5 is prime. So we leave that as radical 5, and then the square root of 4 is on the bottom, and that's 2. Now my very last step to get x alone is to add this 4. So because of the I, and we know that standard form for complex numbers, I comes last, when I add this 4, I'm going to slide it right there in between the equal sign and the plus minus. So 4 plus or minus I radical 5/2. I know it's not pretty, but it's an answer.